Good night everyone. Concrete structures reinforced section analysis. So in this problem we have a 10 feet long cantilever beam with a distributed load of W sub U 2.2 kilo-pound per feet. F prime C of a section provided 5,000 pound per inch squared. Yield the strength of grade 6 is 60,000 pound per inch squared, and we can see the shape of our cross section like provided below. In part A we want to calculate the design moment capacity, which is phi times mn, and in part B we want to calculate the factored ultimate moment, which is mu. Let's approach this problem. So in the first part, so this problem is interesting problem consisting of a two part, which part, the first part is related to concrete structure, and the second part is the relation a problem in structural analysis, and then combining these two problems to get the final answer. We connect these two parts, concrete and structures, together. Let's approach our problem to see how we can approach this problem. So for solving this problem, let's start from the concrete part. As you can easily see in this problem, you can easily verify that the kind of situation in a cantilever beam developed mu, which is a negative moment. If you apply a negative moment to this section, it just seems that you are applying a positive moment to this section. So it simply says we can flip-flop our section by, we can just turn it like 90 degrees, and by this analogy that a negative moment effect on this section is exactly like it, because this moment pulls the top and pushes the bottom. So if you just flip-flop the section and you have your concrete the rebars at the bottom, it just again the same effect. It just, this moment pulls the bottom, pulls the tensile part, and pushes the other side, which is pushes this part. We just flip it like upside down section. And now the calculation is pretty simple because it's like a normal reinforced concrete section. And we want to easily calculate nominal moment. So let's approach the problem by having a negative moment. Again, we can simulate our problem like a simple reinforced section moment. So let's approach the problem. So in such problem, AS is 2 times number A3 bars is 0.79, and it just gives us 1.58 inches squares. Effective depth is 20, height minus 3 inches gives us 17, and we just assume we flip-flop our section. So in part A is AS times F5 over 85%, F prime C times B, which is the width of the section, like here, 12 inches, and it just gives us AS 158 times 60, which is grade 60 steel, over 85%, F prime C, which is 5,000. We just replace 60,000 and 5,000 by 60, and times B, which is again width of section, and it just gives us A, height of fitness block is 1.86, C is equal to A over beta 1, and it just gives us a neutral line or axis equal to 2 point, and you can easily check your ductility. C over dt 2.32 over 20 minus 3 is 70, and it just gives you 0.137, which is definitely smaller than 0.375, which is tension controlled checked, and this is already, we discussed about this in previous concrete video, you can video them. That's related to ductility check for grade S60 steel rebars. And then for calculation of nominal moment, ASFY times the R, force times R gives us the moment, area of steel times grade 60 times D, which is 70 minus half of A over 2, that gives us a 1523, almost 1500 kilopound inches moment. Mn is equal to 126.9 kilopound feet if you pound feet if you divide it by 12, and then phi times Mn is equal to 114.2 kilopound feet. And then if you just move to the structure part, if we just convert this distributed load to a concentrated load applied at the center in part B, mu, the ultimate moment, should be definitely smaller or at last equal to phi times Mn. That's how we can connect our concrete structural part to concrete. This is structure analysis part, structural analysis, and this is concrete structures. And if you just by having this equation, you can easily connect the two parts. So let's see how that goes. 2.2 times 10, length of it is 22k, applies at the center, which is 5 feet, and then it just create a negative moment here, and Ra is 22. That's all the forces should cancel out by the only support at the fixed end support. And then if you cut it through like at 5 feet, it just gives you mu minus 22 times the length, which is 5 feet, equal to 0, and it just gives you ultimate moment from structure 110. And from the other part, you can easily see that's less than phi times Mn, so your section is good enough. Thank you. We'll solve more videos.